Welcome back, students. In the last video we discussed or we solved a few textbook problems. In this video we will discuss board problems, a few sample board problems. So on your left you can see the topics covered so far: basics, introduction, where you introduce to current, voltmeter, ammeter, voltage, all that, zero error in those devices, what is electric circuit, what is schematic diagrams, difference between insulators, conductors, resistors, the what is meant by resistance, what are the factors it depends upon, the arrangement of resistance in series as well as parallel. Last two videos we have been discussing textbook problems. So now we go to the board problems. So this is a quite repeated pattern. More or less something similar is keep repeating in most of the questions in the past. That is, you have been given a length of a wire which is being stretched or drawn to a particular length, like twice or thrice or whatever, and they give you a original resistance and you need to find the new resistance of the stretched wire. So this is 2025 All India paper. The wire of length L is stretched so that it increases its length by 3L, means it is becomes longer by 3 times. If its original resistance is R, then what is the new resistance of the stretched wire? So we have four options: 3R, 6R, 9R and 27R. Before we solve the problem, let us understand the key concepts of what happens when a wire is stretched. When a wire is stretched, two things change. First, the length increases. Obvious, because when you stretch a wire, the length increases. Cross-sectional area decreases. So keep in mind, the cross-sectional area also decreases. But one thing doesn't change. This one thing is going to be a key to solve the problem. The volume remains same. See, whether the wire is 1 meter in length or it is drawn to 3 meter in length, the amount of material, that is the volume of the material of the wire, remains the same. Only thing, the area decreases, length increases, the overall volume remains constant. So you need to be well aware that volume before and after stretching the wire remains the same. Now, how does this change impact resistance? That is the change of length and a decrease in area. Resistance is equal to rho L by A, where the resistance is dependent upon directly on the length, directly proportional to the length. Means if the length is doubled, resistance also doubles. The length is made 3 times, the resistance also becomes 3 times. The second aspect is the area decreases. We saw there are two changes. One is increase in length, the other is decrease in area. The area is inversely proportional to resistance. Means if area doubles, resistance becomes half. See, now area is 1 square meter or square centimeter, whatever. When it becomes 2, the resistance reduces by half. So they are inversely proportional. With these key ideas, let us try to solve the problem. So this is the question, whatever is given, and we are going to very clearly write volume of the wire is equal to cross-sectional area into length. So this is your basic mathematical formula. Area into length is equal to volume. This area depends upon whether you have a square wire or a circular wire. Mostly it is circular wire. I don't have come across anything on square wire. What should you come across? It's just multiplication of the length of the sides. So let A1 and L1 be the initial area and length. Means before you stretch the wire, whatever area and length, that is called as A1 and L1. After stretching, whatever you get is the A2 and L2. So the volume is going to be multiplication of area 1 into length 1, area 2 into length 2, which is remains the same. That's what we just now saw. So A1 L1 is equal to A2 L2, which is same is what we saw, or that is a key concept. So after you lengthen it, after you draw it, the length L2 is 3 times L1. So this value you are going to substitute in the place of, in this value you are going to substitute in the place of L2. Okay. Then A1 L1 is equal to A2 into 3L1. So L1 gets simplified. So whatever you are left with this, A1 is equal to thrice A2. So now what is, now you have got the relationship between, so you have the relationship between length, that is length is equal to 3L, and area also you have got a relationship, area is equal to 3 times A1 is equal to 3 times A2. Now, how to see the impact on resistance? The impact on resistance is, before stretching whatever the resistance R1 is equal to rho L1 by A1, and after stretching is equal to R2 is equal to rho L2 by A2. So you are expected to find the ratio. What is the new resistance like R2? What is the new resistance R2? That's what you are expected to find out. So you can make it as a ratio. R1 by R2 is equal to this row and this row gets cancelled, and you have L1 by A1 divided by L2 by A2, which upon simplification becomes L1 into A2 by L2 into A1. This, now you are going to substitute the different values. L1 is equal to A2 divided by, after stretching, L2 is equal to thrice L1. So you are going to substitute that value. And in the previous calculation, you found out area 1 is equal to thrice area 2. So you are going to substitute that value also, thrice area 2. So you are just left with all the common values which you can easily cancel. L1 goes away, A2 goes away, and R1 by R2 is equal to 1 by 9. Whatever you are left with is 1 by 9. That is 3 into 3. So this is left into 3 into 3, 1 by 9. So R2 is equal to 9 times R1. This is the answer. So this is the second problem, which is similar. How will the resistance of a wire be affected if its length is doubled and radius is doubled? There are two different scenarios. Both are not related. Two different scenarios. They are asking you to justify your answer. So resistance is directly proportional to length and inversely proportional to area. When length is doubled, resistance doubles. Okay. So this is your justification. See, this point has to come out first very clearly. Only after writing this, you are supposed to solve it. Then radius is doubled. Radius is linked to area. When it is given radius, it is understood it is a circular wire. The wire is circular in shape. So when area is doubled, the resistance decreases by 4 times. How? This is because area of a circle is pi into r square. That is the radius square. Radius is doubled. So area increases by 4 times. R is equal to rho L by A. So whatever area increases by 4 times, due to the inverse relationship, the resistance decreases by 4 times. See, this video I'm discussing all the related problems around this change of length, change of area problems which affect the resistance. So in the next video we will discuss the other patterns. This video will focus only on the same kind of pattern. Now we have another problem is 2021. A cylindrical conductor of length L and uniform cross-section area has resistance R. Find the area of cross-section area of another conductor of same material and same resistance, but length is 2L. This is slightly modification of the same pattern. See, they are not pulling the wire or they are not increasing the length. You have two different wires. And between them, both of them have the same material, means both of them have the same resistivity. The value of rho remains the same. Value of rho, resistivity remains the same. And R also is same. So value of R also remains the same. So you need to find out the area of cross section. So it is slightly play around that formula. So let us see how to do. So resistance of first material is equal to R is equal to rho into L by A. Let R dash be the resistance of the other material or the another conductor is equal to rho into L dash. I can put L dash, but I have the value that the length is twice the other material. So I am directly substituting 2L by A dash. Now you are required to find the cross-sectional area of other conductor. Your focus is A dash. So remember, you are required to find out this. Okay. According to the question, the resistance of both materials is same. So what it says is same material and same resistance. So I'm going to equate both. R is equal to R dash. And even the resistivity is the same. Because of same conductor, resistivity is same. So when I put R is equal to R dash, rho into L by A is equal to rho into twice L by A dash. Row gets cancelled, L gets cancelled. So whatever you are left with is A dash is equal to twice A. You are going to calculate it. A dash is equal to twice A. So this is one of the options. They were given 4 options. A dash is equal to twice A. This is the right answer. So this is from a sample paper. This is not a board paper. This is from a sample paper. A wire having a resistance of 16 ohms is drawn to triple its length. Calculate this new resistance. What is the effect on resistivity? So R1 is equal to 16 ohms. Length is L1 is equal to L. R2 you are supposed to calculate, and L2 is equal to 3L because it is drawn to thrice the length. And the key learning is the volume remains the constant. So L1 A1 into L1 is equal to A2 into L2. L1 we saw is L. So A1 into L, this value of L1 is equal to L. I am substituting here, and A2 into L2. L2 is thrice L. So that goes here. So then now you need to just simplify the equation. On simplifying, you find A1 is equal to thrice A2. This is the relationship between area. So to find the resistance of the new condition, you are just going to substitute like how we did in our original problem. That is the first problem. R1 by R2 is equal to, you are going to substitute this value of R1 R2 is equal to A1 L1 divided by A2 L2. So upon simplification, it becomes L1 into A2 divided by L2 into A1. You substitute the values, whatever is known values. L2 you know is 3L, A1 you know is 3A2. Okay, substitute all the values and simplify it. Upon simplification, you will reach R2 is equal to 9R1. R1 is 16 ohms, you know that. So that you are going to substitute here. 9 into 16. 9 into 16 gives you 144 ohms. So that is the answer. So next problem next video we will discuss other pattern of board problems. Bye and thank you till then.